Okay, so today we'll find the probability of dependent events, right? Previous lesson was independent. This is going to be dependent, which means it depends on what has already happened. I think the easiest example to explain is the 10 marbles in the bag. Again, I'm going to draw out one at a time. The key difference, though, is after I take a marble out of the bag and record the results, I do not put the marble back. Right? I keep whatever has been drawn and hang on to it. This is called without replacement. So let's see what would be the probability of drawing a purple marble 3 times in a row. Well, first time I tried draw a purple marble, well, there'll be 10 marbles in the bag. 4 of them are going to be purple. So the first time I try draw a purple marble, I will be successful 4 times out of 10, which reduces to 2/5. Now let's pretend I'm successful and I did grab a purple marble. And so now I'm going to try a second one. Well, this time I reach in there are only 9 marbles in the bag, and only 3 of them are purple because I've already removed a purple marble. So the probability has now changed. There's only 1 chance out of 3 that when I reach in the bag, I'll get a purple marble. Now let's pretend I'm successful again. So I got a purple marble on the first draw. I got a purple marble on the second draw. Well, now there are only 8 marbles in the bag, and only 2 of them are purple. So now the probability that I'm going to get a purple marble is just 2 out of 8, or 1/4. That's why we call this dependent probability. The result of any one of these actions depends on what has already happened. Right? So if I want the probability of purple followed by purple followed by purple, and I'm doing this without replacement, I would have 2/5 times 1/3 times 1/4. That is 2 out of 60, which of course reduces to 1 out of 30. Okay, again, same bag of marbles, so let's start all over with all 10 in the bag. Let's find the probability of drawing a blue marble 3 times in a row without replacement. Well, I'm going to reach in that bag. There are 10 marbles. 2 of them are blue. 2 over 10 reduces to 1/5. Now there are only 9 marbles, and only 1 of them is blue. So my probability is now 1 out of 9. Finally, I reach in a third time. There are only 8 marbles, and none of them are blue. My probability is 0 out of 8. That's 0. So the probability that I'll get blue, followed by blue, followed by blue, 0. It's not going to happen. Right? There are only 2 blue marbles in the bag. There's no way I can get 3 of them. So the probability of drawing a blue marble 3 times in a row with replacement. Oh, sorry. Reread this correctly. So now, let's go back to the previous lesson, and let's find the probability of drawing a blue marble 3 times in a row with replacement. Right? We actually did this on the previous lesson. And of course, if 2 out of 10 are blue, that'd be 1/5. And so if we were to replace it each time, then the probability would be 1/5 times 1/5 times 1/5, or 1 over 125. So that's still pretty unlikely, but at least it is possible. Okay, so let's hang out with our marbles again. What if I want the probability of drawing a green or purple marble 2 times in a row without replacement. Right? So we draw one and we keep it. We don't put it back in the bag. Well, the first time I reach in for green or purple, it's 7 out of 10. If I'm successful, now there are only 9 marbles in the bag and only 6 of them are purple or green. Of course, I can reduce 6/9 to 2/3. And I can even do a little bit of cross-canceling there. And I finally end up with 7/15. That's my probability. Now, what if I wanted to try to do the same thing, but with replacement? So I want either a purple or a green 2 times in a row, but I'm allowed to replace. Well, 7 out of 10 are either purple or green. And since I'm allowed to replace, it'll be 7/10 times 7/10, which is 49/100. Right? So slightly more likely that I'd be successful if I was able to do that with replacement. Okay, so the computer circuit board says we have a worksheet. All right. Have at it again. Email me with questions. If we can't solve questions via email, we can even do a Zoom call.